Betelgeuse, a red supergiant star in the constellation Orion, has captivated humanity for centuries with its remarkable size and brilliance. Positioned about 642 light-years from Earth, this colossal star is one of the most luminous objects visible to the naked eye, making it a celestial beacon in the night sky. Its extraordinary dimensions challenge our understanding of cosmic scales. If Betelgeuse were placed at the center of our solar system, its outer edges would extend well beyond the orbit of Jupiter, enveloping the inner planets, the asteroid belt, and parts of the outer planetary orbits. This unparalleled scale and prominence have made Betelgeuse a focal point in the study of stellar evolution and the life cycles of massive stars. The intrigue surrounding Betelgeuse extends beyond its physical characteristics. Recently, astronomers and enthusiasts alike have observed significant fluctuations in its brightness, with dramatic dimming episodes followed by unexpected brightening. These irregular patterns have sparked widespread speculation about the star's fate, leading many to conclude that it is nearing the end of its life. Such changes are often associated with the later stages of a star's evolution, when it exhausts its nuclear fuel and transitions toward its final cataclysmic phase, a supernova explosion. When Betelgeuse eventually explodes, it will produce one of the most spectacular phenomena in the universe. A supernova is a powerful stellar event, marking the violent death of a massive star. It releases an immense amount of energy in a brief period, illuminating the cosmos and outshining entire galaxies. For Betelgeuse, this explosion could be visible even during the daytime, rivaling or even surpassing the brightness of the moon in the night sky. Such a display would last for weeks or months, providing a once-in-a-lifetime celestial spectacle for observers on Earth. Beyond its visual impact, the explosion will offer an unprecedented opportunity for scientific study, allowing researchers to probe the intricate mechanics of a supernova in real time. The life of Betelgeuse. Betelgeuse began its life as a massive, luminous star, much larger and more energetic than our Sun. Like all stars, it initially generated energy through nuclear fusion, converting hydrogen into helium in its core. This process, which has powered Betelgeuse for millions of years, releases vast amounts of energy, producing the light and heat that we observe. However, the larger a star, the shorter its lifespan. While smaller stars like the Sun can sustain nuclear fusion for billions of years, massive stars like Betelgeuse burn through their fuel at a much faster rate. As Betelgeuse aged, it exhausted the hydrogen in its core, triggering the fusion of heavier elements such as helium, carbon, and oxygen. These elements provided temporary sources of energy, but each stage of fusion occurred more rapidly than the last. Eventually, Betelgeuse began producing iron in its core. Unlike lighter elements, the fusion of iron does not generate energy. Instead, it consumes it. This critical juncture marks the end of a star's ability to resist the inward pull of gravity, leading to the collapse of its core and the onset of a supernova. The mechanics of a supernova. A supernova is the ultimate fate of a star like Betelgeuse. When the core collapses under its own gravity, it triggers an explosive release of energy. This event, known as a Type II supernova, occurs in several stages. First, the core implodes, compressing the matter into an incredibly dense state. This compression generates a shock wave that travels outward, violently expelling the star's outer layers into space at incredible speeds. The explosion releases a vast amount of energy, producing visible light, gamma rays, and other forms of radiation. The materials ejected during a supernova include heavy elements such as iron, gold, and uranium, elements that are essential for the formation of new stars, planets, and even life. In this way, a supernova represents not only the end of a star's life but also a crucial step in the cosmic cycle of creation and destruction. The heavy elements dispersed by the explosion will eventually become part of new celestial bodies, continuing the universe's dynamic evolution. Betelgeuse's unprecedented opportunity. The study of Betelgeuse offers an unparalleled opportunity for scientists to explore the life and death of massive stars. Its proximity to Earth, only 642 light-years away, makes it an ideal candidate for detailed observation. Unlike more distant supernovae, which are often obscured by interstellar dust or too faint to observe clearly, Betelgeuse's explosion will provide a vivid and detailed view of this cosmic phenomenon. Astronomers are currently using advanced ground-based and space-based telescopes to monitor Betelgeuse closely. These instruments include the Hubble Space Telescope, the James Webb Space Telescope, and various neutrino and gravitational wave detectors. Observatories equipped to detect neutrinos, such as Japan's Super Kamiokande and the Ice Cube Neutrino Observatory in Antarctica, are on high alert. Neutrinos are subatomic particles that travel through matter with little resistance, often preceding the visible light from a supernova by hours or even days. Capturing these fleeting particles will provide critical insights into the star's final moments and the processes leading up to its explosion. The cultural and scientific significance. The eventual supernova of Betelgeuse holds profound cultural, scientific, and philosophical implications. Humanity has gazed at Orion and marveled at Betelgeuse's brilliance for millennia, weaving the star into myths, legends, and scientific inquiry. Its disappearance from the night sky will serve as a poignant reminder of the transient nature of the cosmos and the constant cycle of creation and destruction that shapes the universe. On a scientific level, the explosion will offer invaluable data that could revolutionize our understanding of stellar evolution, core collapse physics, and the distribution of heavy elements in the galaxy. Instruments like LIGO, Laser Interferometer Gravitational Wave Observatory, and Virgo, designed to detect gravitational waves, will also capture critical information about the dynamics of the star's collapse. These observations will refine existing models of supernova mechanics and provide deeper insights into the forces that govern the cosmos. The role of Betelgeuse in the cycle of cosmic evolution. Betelgeuse's eventual death is a vivid example of the interconnectedness of celestial phenomena. The elements it releases during its supernova will enrich the surrounding interstellar medium, providing the raw materials for new stars and planets. Over millions of years, these materials will coalesce into new celestial structures, continuing the cycle of cosmic evolution. This process underscores the idea that the universe is a dynamic, ever-changing entity, where death and creation are intrinsically linked. The same iron in our blood and calcium in our bones were forged in the cores of ancient stars that exploded billions of years ago. Betelgeuse's explosion will contribute to this ongoing story, seeding the galaxy with elements that may one day become part of new worlds and even life itself. Anticipating Betelgeuse's final act. As we await Betelgeuse's eventual explosion, astronomers and the public alike are filled with a sense of anticipation and wonder. This once-in-a-lifetime event will not only illuminate the night sky but also highlight humanity's boundless curiosity and ingenuity. The data collected from the explosion will shape the field of astrophysics for decades to come, offering new insights into the forces that govern the universe. While the timing of Betelgeuse's supernova remains uncertain, its occurrence is inevitable. Whether it happens within our lifetimes or thousands of years in the future, the event will leave an indelible mark on human history and our understanding of the cosmos. It will serve as a powerful reminder of our place in the universe and the interconnectedness of all things. Betelgeuse's impending supernova is not just an astronomical milestone, but a moment of profound significance for humanity. It represents the culmination of decades of scientific observation and research, as well as humanity's enduring fascination with the stars. When the light from Betelgeuse's explosion finally reaches Earth, it will illuminate not only the night sky but also the ingenuity and curiosity that drive our exploration of the cosmos. This monumental event will inspire awe, wonder, and a renewed commitment to understanding the universe, leaving an enduring legacy for generations to come.